Alright, so today we're going to learn another trick in our repertoire of working with solving equations. Okay, so today, and I'll make the list so that we can all see it. Whenever you're solving equations, what you see and what you do are two different things. They're actually going to be inverses of each other. So if you see addition in a problem, you're going to do subtraction on the other side. If you see subtraction, you're going to do addition. Okay, pretty simple stuff. If you see multiplication, you're going to do division. All right, hold on, let me get that symbol. Where is it? And if you see division, you're going to do multiplication. Okay, so some pretty simple stuff. Now we've also learned if you see squaring something, you are going to square root it. Now today we're going to learn is what happens when you see a square root. You're going to square both sides. Okay, so like for example, if you see the square root of x minus 3 equals 6, okay, you're going to add 3 to both sides, and we are going to get the square root of x equals 9. Okay, and then what we're going to do is to finish this off, because we're going to do the inverse operation, because working backwards is doing the inverse, is we are going to square both sides. Okay. Alright, now you do not need to worry about the plus or minus because you're actually doing the problem. Now here's the thing though, you need to check it. Why? Because of that rule, in that if you try to do the square root of a negative number, it is not real. Okay, so we want real answers only. So you need to check it. Square root of 81, we'll plug it in here. Okay, and what we're going to get is the square root of 81 minus 3, and does that equal 6? And I believe it is, because this is going to turn into the 9. So that actually works out pretty darn well. Alright, now what we're going to do is we're actually going to work on some more problems, except I'm going to show you if the square root goes over the entire thing. So something like this. Let's say the square root of x plus, let's do x minus 4 plus 3 equals 4. There we go. Alright, so this one is a little bit interesting. What you're going to do, once again, whenever we're working on this type of stuff, you're going to get rid of the stuff outside, because you always do subtraction. You always do addition and subtraction first. Okay, so this is going to turn into the square root of x minus 4 equals 1. Okay, so what I'm going to do is I'm going to square both sides. Okay, at this point. Now when you square that, this is the really cool part, you're multiplying this by itself, but this is just going to be it squared. So guess what? Those two cancel out. That's the beautiful thing about this, is it takes a really complicated equation that we began with and has it like this. Okay, alright, so now what you're going to do is you're going to add 5 to both sides. Okay, and x equals 6. Okay, and so what you're going to do is you're going to plug that back in, because you have to, because we can't do square root of a negative. Well, we can, but it's going to get us an imaginary number. Okay, and we're going to simplify it. So the square root of 6 minus 4 plus 3 should equal 4. Okay, well, the square root of this, so 6 minus 4 is going to be the square root of 2. Okay. And the square root of 3 is actually not 4. Okay, so what happens when you have this is you're going to have no solution. You're going to have no real solution. And what that actually makes this is that makes that an extraneous solution. Okay. 6 is an extraneous solution. In other words, it's a solution that even though it fulfills all the requirements, we did the math correctly, when I plug it back in, it actually does not make sense, and nor does it work. Okay, so that's an extraneous solution. Okay, now if we had to solve something that looked like this, let's say the square root of 3x plus 1 equals the square root, and you can actually have square roots on both sides, of 5x minus 8. Okay, now the cool thing is I have nothing to get rid of on the outside, so I can just basically square both of these sides. Okay, all right, that's pretty simple. Now what happens when I square them? I'm just left with 3x plus 1 equals 5x minus 8. Okay. All right, and then what I'm going to do is I'm going to solve this. I'm going to minus the 3x from both sides. And 1 equals 2x minus 8. Okay, then I add 8 to both sides and accidentally gave away the answer. All right, so this is going to be 9 equals 2x. And then I'm going to divide both sides by 2, and so 9 halves equals x. Okay, now what I'm going to do is I'm going to actually plug that back in and then just do the square root to both sides and see if I actually get the actual solution. Okay, now you can treat this as 9 halves or you can treat this as 4.5. It's up to you. Okay, so when I plug it back in, this is going to be the square root of 3 times 4.5, which is 13.5, and 13.5 plus 1 is 14.5. Okay, and then over here it's going to be the square root, let me see, 5 times 4.5 is going to be 22.5, and 22.5 minus 8 is definitely going to be the square root of that. So this actually checks out. So this is not extraneous. This is an actual solution. Okay. All right. Now this is probably going to be the more complex part you're going to be dealing with. If you notice, there's nothing to deal with out here, and we just got an end. So we're going to be squaring both sides. Once again, squaring gets rid of the square root. So square, boom, boom. But this is just going to be an n squared. So 12 minus n equals n squared. Okay, now what I'm going to do is move everything over to this side. Oops, there we go. I'm going to move everything over to here, okay, and just get 0. And if you see where I'm going with this, so this is going to be n minus 12. Okay, now what I'm going to do is actually do the zero product property. In other words, I'm going to factor this. So it's going to be 0 equals n minus 3, parentheses, n plus 4. Okay, and I'm going to set up each part of those equal to 0 because they could be equal to 0. Okay. All right. Now, what you could also do is you could just easily graph it and see where it crosses the x-axis. That's totally fine, but I'm just doing the math really fast. Okay, so you get n equals 3 or 4, or sorry, negative 4. Okay, now here's the tricky thing, is that normally in the past we would just accept these two answers and move on. But here we've got to check them both. So I'm going to plug in 3 and see if that works. So I check it out. The square root of 12 minus 3, does that equal 3? Okay, and if you notice 12 minus 3 is going to be 9, so yes, that checks out. So this is good. So I'm going to keep this. Okay, and then I'm going to check the other one. So the square root of 12 minus 4 is going to equal 4. Okay. Oh, sorry, negative 4. So that's going to be minus that negative 4, and is that going to be equal to negative 4? Okay, if you notice, a double negative is going to turn into positive, and that is definitely going to be 16. And this one actually does check out for both situations. So yes, it actually works. So these are both acceptable answers for this situation. Okay, now some of you guys are going, whoa, 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 hold on. You can't square root a positive and get a negative? Yes, you can, because guess what? Negative 4 times negative 4 is definitely 16, so that definitely checks out. Same as here is 3 times 3 is 9. Guess what also works? But we're not going to consider because we're not using it right there. And same thing here. Okay, but we don't consider these second two because we only need this situation. Okay, all right, so n equals 3 or negative 4 is actually correct and will work in this situation. Just as long as I don't get a negative inside the square root before I do square rooting, I'll be fine. Okay. All right, and that's the most complicated one you're going to see in Algebra 1. In Algebra 2, just to give you a preview of where you're going, you might have to do square root of like n minus 3 equals n plus 5. Now, if you notice right here, and just be thankful you're not in Algebra 2 yet, okay, you might square both of these. But what you're going to get is a nice n minus 2 on this side, and this is going to be n squared plus 10n plus 25. So you're going to actually have to multiply that out. All right. That's not too hard to work with, but it actually can be useful when you're working in this stuff. But this will be just Algebra 2. Okay, so you don't have to see any of those problems on this in this course right now. Okay, all right, but that's where you're going with solving radicals. I will talk to you later. Bye.